Good evening, everyone. Good afternoon. Good morning. This is George Osimbo, and on behalf of LMSK, I'm privileged to take you through this webinar as a moderator. So today's webinar, you are welcome and highly welcome to participate. This webinar is community to be accredited. It will attract 3 CPD points, and therefore we'll be able to upload for you the points on the CPD portal. So at this point, I would like to welcome our presenter for today's webinar.
Thank you so much, Bwana George Osimbo. It's a pleasure to be here. Thank you. So, Bwana George, do I continue?
I hope you are there. I'm introducing you and you will proceed shortly. I hope you can hear me.
Yes, I can hear you now. Thank you.
Great. So I was in the midst of introducing you. In the meantime, you can check on sharing your screen. So as we proceed, Mr. David Chege has participated as a laboratory manager in an institution, actually leading clinical trials and also providing strategic leadership in laboratory operations. Mr. David Chege has served as a laboratory coordinator at Aga Khan University, Precise Study. He's also served as a lab technologist, medical laboratory technologist at Aga Khan Hospital Outreach, and also AAR Healthcare. So today we are bringing to you an exciting topic about GCLP, and so please, you are invited to take part in this. If you have any question, kindly use the Q&A chats, and also invite your friends. The topic for today is diagnostic aids, good clinical laboratory practices guidelines. So, Mr. David Chege, kindly take the platform. As you share your screen, you can start. Mr. David, if you can hear me.
I don't know whether you can
Mr.
see the
David,
screen.
if you can hear me.
Yes.
On my end, I cannot see the screen. I think you can reshare it.
Okay, let me try to reshare it.
You can stop and then start sharing again.
Okay.
So members, as our presenter is working on the technicality, we are calling you to always use your correct details and also adhere to the timings or rather the duration that you take on our webinars. As much as we provide the CPD points and upload them for you, it is very important that you imbibe the knowledge that is being shared on our platforms. We are very keen on the topics that we put in line for the medical laboratory practitioners, and also the timelines that we give for the presentations. We ensure that all the topics, all the objectives, and any concern is well handled. And so we provide adequate time for that. And we hope that the time that we provide or the time that we allocate is helping, is benefiting everyone, and also making people to have enough time to learn. We hope that whatever we provide, the knowledge that you gain here, they are well practiced in our labs or where we work. And so we are always very happy and appreciate your feedback that you usually give because of our excellent service that we provide. Among us just here, we are diverse in our today's participation and even in our usual participation. There are diverse groups here, and actually the entire region, the entire country is represented here. I can see Kaya Metcalf. Oh, it's my first time to be reading such names. Kaya Metcalf. Wonderful. Metcalf is from Nairobi. Frida Yukena from Siaya. Feel welcome. Feel welcome. Barasa Boniface from Nairobi. Karibu sana. We're very happy for you. From Bomet, we have Kipkoech Johanna. Thank you very much. We appreciate the presence, and we also acknowledge Samson Ogwalo. Samson Ogwalo is saying jambo from Nyakach. This is wonderful. Karibuni sana. We have Timothy. Timothy is from West Pokot. Thank you very much for considering LMSK as your leading CPT provider. This is quite encouraging. Thank you very much. We also appreciate Franklin Comino. Franklin Comino is from Kisumu. Feel welcome. Oh, we have also a representation from Mombasa here, Muhammad Makuzimu. This is wonderful. Michael Masharia Njenga from Eldoret, Bondo, Wycliffe Mbadi. Wonderful. Thank you very much, Mbadi, for considering LMSK as your most preferred, most efficient, most affordable, and all good descriptives as far as CPD provision is concerned, and also knowledge sharing. This is great. Vincent Maiwa from all the way from Garissa. This is wonderful, quite encouraging. Sela Kipkoech from Meru. We acknowledge your presence. And so at this juncture, I would like the presenter now to take up the stage, since now I can see that the presentation is now clear. So Mr. Chege, kindly take up the stage and start. Thank you very much, everyone.
Thank you so much, Bwana Asimbo, George Asimbo. So for today's session, we're going to discuss about the GCLP. The key difference between the GCLP and GLP, that is good lab practice, is only that the GCLP has the clinical trial component in it, incorporated in it, for the safety of the participants. I know you have already read or heard about other standards. The other standards are like, for the UK, we have the RQA, that is Research Quality Association. We have LQMS from the WHO. We have also the SLIPTA under the WHO. So this one is just GCLP under the dates. DAIDS is a division of AIDS, which is a branch of the National Institute of Allergy and Infectious Diseases, that for any study to be approved, they must undergo the GCP DAIDS guideline and have met all the qualifications. So this is just an additional standard from what we are using in our facilities. So we can dive into, whether you can see it, dive into the presentation. So for today's presentation, we'll have the following objectives that we're going to meet. We're going to meet the following standards under the test and control. These are module 4 for the dates, GCLP. Because module 1 is organization and personnel, module 2 is equipment, module 3 is test facility operations, and now we're going to handle module 4, that is test and control. And it has the following standards. We have the quality control program standard. We have the evaluation criteria standard. We have frequency of control, or quality control testing, and type of control materials. We have also a standard called review of quality control data. We also do have corrective action logs, quality control, corrective action logs. We have supervisor review of quality control documentation. We also have quality control record retention. Then we will talk about the standard of labeling and storage of quality control materials and reagents. Then we shall talk about the parallel testing, lot release, or what we refer to as lot testing, and then reagent equivalency. Then we shall talk about the water quality testing, and finally we'll have a QC for our microbiology media. So today's session, feel free to interact with me, and I will be able to take you through those particular standards in our 4th module. So let me just give you an overview of this particular topic, of this particular module. So most of the time when you're doing quality control, we need to have a process identification. We need to have a process of identifying and documenting of all the analytical problems that may occur in our facilities. Okay, so the main agenda of us doing that is to have accuracy and reliability of the analytical testing processes that are in our facility. So as a lab, we must have a process that is able to identify these particular errors immediately they occur, and then document the changes that happened over that particular time. Okay. Then finally, it is also important to have a frequency of the performance and the number of samples or specimens to be used in this particular QC, and as well as the type of the QC materials that you're going to use. And this must be taken into consideration of the particular analyte you are analyzing at this particular time. And then an investigation or a CAPA must be handled accordingly and documented so that you can have traceability of your QC program. Okay, so now we can start with our first standard. So our first standard is quality control program. So in our quality control program, we shall be having, we are talking about a site-specific written QC program. Most of the lab, they have a quality manual or quality SOPs, several of them. So we must have that are site-specific. To define the procedures for monitoring analytical performance, this program ensures there is consistency, identification, documentation, and resolution of the QC issues as they appear. We're saying we need to do them immediately. And then for oversight, the laboratory management team must be involved. Most of the time we have the lab director, the lab manager, the lab QC team, and also the deputy lab manager who are involved in this particular process. Then the standard number 2 about the evaluation criteria. So under evaluation criteria, we're talking about the manufacturer's tolerance limit. This is the upper and the lower limit. And for tolerance limits, for those people who have done the reagent, yeah, those people who have done reagent acceptability, or what we call, especially when you have a new reagent in your facility, or you want to introduce a new test in your facility, there are those acceptability criteria. One of the things that you need to do, you need to set your upper and the lower limit. And most of the reagents that come into the facility, they have the tolerance limits. A good example that I can give you here is, for example, if you're doing glucose testing. Glucose testing, you have that your equipment can only test a minimum of around maybe 2 millimoles per liter and an upper limit of around 30 millimoles per liter. So as a facility, it's good for you also to have a tolerance limit that you set for your facility. There's some facility that says, let us set our limit, tolerance limit from between 5 to 20, so that anything that the equipment tests below that or above that is considered to be way above the acceptable limit. And this one will trigger maybe a critical action process to be initiated. Then for some labs, as we do that, you may have, there's some facilities that they want also to establish their own mean, especially for clinical chemistry. And in this, they use around 5 to 21 samples. Maybe they can do this over time, maybe between 5 to 21 days, depending on the how busy your facility is. As long as you have a minimum of around 20 replicates, you'll be able to get your own CV and also get your own mean. And using these particular replicates, you can be able also to have your standard deviation, so that when you're having your multi-rule QC procedure to judge the acceptability of this particular analytical run, you may be able to now have your own localized that you already identified, depending on the local population that you do have. So that standard is about the frequency of quality control testing and the type of quality control materials. Most of the time, you have your participant samples, and you know that when you're analyzing these participant samples, the QC sample must be analyzed the same way you analyze the participant sample. So this one goes to the equipment, goes to the personnel, goes to the environment. So do not treat these QC materials as different. You also treat them as participants. Okay, and then the management must also determine the appropriate number of frequencies that you are able to do this particular QC sample. There are some facilities that say we are going to be running this QC on a daily basis. There are some facilities say we are going to be running them on a weekly basis. And there are some that say anytime you have a run, whether it's on daily basis or on weekly basis, as long as you have a new run, you must incorporate a QC run, that particular run. Then for the quantitative tests, you must have a minimum of 2, that is a high and a low level. For most of the people who are doing chemistry, they do have a PPU and a PNU, so that they have the highs on their end and the lows on their end. For people who are doing hematology, I know you have the 3, at least that is more than 2, that is more than 1. At least you have 3, you have your high, normal, and low run, your QC run. Also, it's also good to note, controls must verify assay performance as a result of levels where clinical or study decisions are made. This one is given an example of maybe you're doing a glucose level, and if a participant maybe acceptance criteria is between maybe 45 and 80, you see that the study participant glucose level, if it's between 45 and 80 milligrams per dl, the two level controls, that is the upper and the lower, must incorporated in your run so that you're able to capture those people who have very low glucose levels and those people who have very high glucose levels. For qualitative tests, this is your positive or negative. You must incorporate positive and a negative. And it's important that you have maybe a very weak positive so that you can see whether your kit is actually running well. So when you're doing your runs, make sure you include at least a very weak positive. Negative is okay, but a weak positive, the kit will be able to tell you how well it is. There are some people who also do some serial dilutions to see whether this particular kit can be able to obtain this particular organism or analyte. We can go now to the staining procedures. For stains, most of the labs are doing gram stain. So it's important that you include your gram positive and your gram negative as a control. Most of the time, I know people use either staph or strep, or for gram negative, they use E. coli. So it's important that you have these particular organisms and make sure you document. And this must be done either on weekly basis or each time you change the lot number of your stain. So every time you are maybe every morning, if you are planning to do a gram stain, you must have a gram positive or a gram negative control run that are incorporated in your runs. For FDA approved and clear waved tests, these are mostly, if you hear FDA approved, these are what we call the over-the-counter most of the time, and also there are some few tests that FDA have approved that you can be able to do maybe slightly. It's not really necessary to incorporate, but it has an inbuilt QC system in it. An example is when you're doing your urine pregnancy and your HIV. For it to be approved by FDA, there must be a QC component in that particular kit, so that now anybody or most of the people, even not highly trained people, can be able to run them. And this one, it's recommended also to have an EQA for this particular test, and it's recommended to do it on weekly basis. But we know because of the resource constraint, it's not possible to do it on weekly basis. Sometimes we do it on a quarterly basis, maybe after every 3 months. But it must have an EQA component in it. In addition, for you to be able to run the QC, it's highly encouraged that in case your results are used for primary endpoint or critical safety determination, you must have a QC run in there. If there are changes for device reagents, in case maybe you have realized that your QC, maybe a calcium reagent is over, for you to be able to run using that particular reagent, you must have a QC incorporated into that, so that you see whether that particular run will be, the results that you're going to be generating are valid. Also, the study population, if there's a change in the study population, maybe you are used to analyzing adults. Now your studies changed and you're now analyzing children. You must also do a QC change or test for you to know whether the kit is partially keeping up with you. Then for all tests that are not FDA approved, like most of the tests that we do in our facilities, even if they closely resemble the clear waved, the clear waved test, the one we call the over-the-counter test, you must also run a QC test. Each time you have a new lot, especially when you're doing a lot to lot, you must also include a QC run there. Whenever a new shipment or test kit is received, it may be the same lot, but it's a new kit that has been received. So you must do a QC run on it, because you don't know during the transfer from the storage to your facility what might have happened in between there. If the temperatures of the kit storage area falls outside the manufacturer's recommended range, this mostly happens to the kits that are stored at room temperature, where we may have excursions when we have very high temperatures in our facility, or maybe there's a breakdown with the AC. So anytime you look at your chart and you see it's above the manufacturer's recommendation, it's important that you do a QC run there. If the temperatures of the testing area falls outside manufacturer recommended range, that one I've already explained. Then QC must be reviewed by the management, and the run must be reviewed for acceptability. Okay, must be reviewed for acceptability prior to reporting the study participant results. This is very key so that you have very valid runs and you do not have results that are maybe they may have implication on the acceptability of the participant or change of the medication of this particular participant. Because there are also some tests that if a particular level is obtained, this participant is removed from the study and is taken for clinical care. So it's important that these QCs are reviewed for acceptability by the management. And in case you have any critical results, it's important that you contact at least the PI of the study so that they can be able to guide you further. Then the study participant results after a change of the analytical and a critical reagent. For example, maybe you realize that we were using determine to do HIV testing, and then now we need to use a different kit. So in case there is that critical reagent change, you must also do a QC run there. The major preventive maintenance of the equipment. This is routine preventive maintenance or service of the equipment. So after the engineer has left the facility, it's important that you also do a QC run to see whether the equipment is actually working as expected. Or change of critical instrument component. This mostly happens to the chemistry machine or the hematology machine. Mostly for chemistry, maybe you've changed the bulb. You realize now these are very key component in that instrument. But if it's maybe even a probe is also a very key or critical instrument component. So it's important that you be able to do a QC run to make sure that the equipment is doing very well. There are things that maybe a monitor here, maybe a component that is not very critical. So for those ones, you don't need to do a QC run. But it's recommended that every time an engineer visits your facility and they have interacted with the equipment, kindly do a QC run to make sure that you are in good hands. Then the laboratory personnel performing the test must determine the appropriate CA to take for the QC data that fall outside the expected range. So every time you have, maybe you have set for chemistry, you have set your runs is between positive 2S and negative 2S. In case you have, using your Westgard multi-rule, if in case you have maybe a 3S, then you need to have a corrective action. And this must actually be well documented. And then, as we had already said, we must also establish our tolerance limit. How far can we, this one is mostly found in the kit inserts, but it's also important that you also develop yours in-house because there are levels that this equipment cannot be able to attain. Maybe some maybe critical levels, and maybe the study wanted to see the outer limit from your tolerance limit. So you can be able to advise the research team that this is how far our equipment is able to test. Okay. Then so this tolerance limit is usually determined using the QC program as a guide because it has the higher, the upper and the lower limit. Then the CA, that is the corrective action, must be documented with the technician's initials and date. So you must actually document and let us identify the person who has initiated the CA. In the event that the QC data is determined to be unacceptable, like for that instance we have there, that the data has fallen outside the expected limit, the laboratory must reevaluate all the study participant results since the last acceptable run. maybe you have done maybe 20 tests today, and then in the evening you realize that yeah, my QC haikupita or did not pass. So what happens there? You must recall all the test results that you had run that day and make sure that now you repeat all of them after you have established that your QC has passed. Okay. So do not release results which do not have accuracy data, and so that you have a fallback, so that you can say that your run was okay. Then the laboratory must evaluate the study participant results to determine the significant clinical difference that has occurred, because you may analyze like around 20 or 30 samples that particular day, and then you have realized that the QC run is out, but you repeat like around 5 tests and you realize that the difference is not that much. So it's also important for you to first check how bad was this particular difference, so that you can be able to be guided about the performance of this particular instrument. And this will also guide you in when you're doing the troubleshooting and as you amend your reports as applicable. Okay, so this is very key. So the other standard is our quality control logs. So for the quality control logs, this mostly is about documentation, our documentation practices in our facilities here. So QC logs must be present, documenting control results assay with each protocol-related test, as described in each specific protocol-related assay procedure. So this is more or less like a documentation log, so that in case somebody would want to see what happened in this particular day, they have a fallback data which they can be able to check. Then you have control records, must be readily available to the personnel performing the test, so that you can see last week how was the equipment, this week how is the equipment performing. Okay, so this data must be readily available, whether it's in digital or in a paper form, must be easily available to the personnel. Then the results of control must be recorded or plotted to readily detect the malfunction in the equipment or in the analytical system that you do have there. Most of the people, they chart them and they use the Levigening charts, the LJ charts that we do have, and they can be able to check. It's like a visual way of you being able to know that this particular equipment is failing without actually doing a lot of calculation, so that visually, when you look at the chart, you're able to see that this particular equipment, the QC run, has passed or has not passed. So the laboratory personnel performing the QC run, recording of results and plotting of the data on a graph must record their initials, date, and time as applicable. This is key. It's taking personal responsibility, and also saying that you can be able to attach a particular data point to a particular personnel who has analyzed this particular test. Okay, then the QC materials are reported, must be labeled. This mostly happens to chemistry, clinical chemistry, the clinical chemistry department. When you have your standards and your control, or what you refer to as the calibrators and your controls, you have to sub-report them. And once you have sub-reported them, you need to initialize and also do, you label it applicable with the applicable information on that paper. And there are some people who even go further, do an electronic log, so that you can be able to track that particular lot that has been generated there. This is mostly for traceability to the material name and lot, and the preparation date, and the expiry date, and the technician who has developed that particular, who have sub-reported that particular sample. Let's go now to the CA logs. So the CA logs, once you open a CA, it must be documented in your CA logs, and the laboratory must ensure that the corrective action logs or equivalent electronic record is present to facilitate documentation and resolution of the QC failures. so that you can be able to know this. Just for quick reference, you see how many CAs have you generated this particular week, and how many CAs have you been able to generate for a particular month. And this also guides you on quality improvement in your facility. Well, let's go now to the other standard for the supervisory review of quality control documentation. So, appropriate laboratory management must regularly review. This is about the oversight role, management. And the frequency is determined also by the manager. Most of the time, they do it at least monthly. Must review, sign, date, and date the QC records and the corrective action logs according to the following guidelines. One, the laboratory management must review, sign, and date the QC data and the corrective action log at least on monthly basis. Then a listing of all the designee position titles must be included in the current QC plan so that you're able to track the number of personnel that you do have there and who have been doing what in your facility. Let's go now slowly to the quality control records. Retention. So quality control records retention is more about the storage of this particular documentation that we've been able to generate. So the following record must be retained by the laboratory in a secure, preferably fireproof or fire resistant or fire protected area with operational automatic sprinkler system. The storage area or facility for a period of time that has been determined by the laboratory or the institution. Most of the facilities, they store these particular documents for a minimum of 7 years. So this, because of the data that you're generating, it's important that you have at least a secure fireproof area. Then instrument printout. Instrument printout are all QC record, including the worksheets. If QC is recorded manually, package inserts, certificate of analysis, all these ones must also be stored in this particular place. Most of the time, I hear people asking, how do you get the certificate of analysis? There are two ways you can be able to do this. The first way, on the first instance, you can contact your supplier. You can be able to generate for you the certificate of analysis. Or secondly, you can just get the reagent, go into the site of that particular company and request for the certificate of analysis. They'll be able to share with you once you request for those particular certificate of analysis. Labeling and storage of quality control materials and reagents. As you know, for quality control, we have the following reagent. We have the reagent itself, we have the calibrators, we have the controls, we have the stains, chemicals, and solutions that are usually used in this particular process. So all these particular reagents or these particular materials must be properly labeled and stored as applicable and appropriate with the following. One, and when you say as applicable means, there are those that are supposed to be frozen. There are those that are supposed to be stored at 2 to 8. There are those that are supposed to be stored at room temperature. There's some that are supposed to be stored in an incubator. So this depends on the manufacturer's recommendation. So must have, when you store the reagent, you must have the following. At least the minimum end, you must have the content and the quantity or concentration or the title of this particular reagent, dated initials of the personnel who prepared, filtered, or reconstituted the reagent, and expiry date must be clearly indicated there. The deteriorated or outdated, that is generally saying about the expired kits, reagent, quality controls, calibrators must not be used. How do you make sure that you don't use this particular reagent? One, you must have an expiry reagent log so that you document them. There are some institutions that go ahead and put some labels in terms of expired, then remove them from your workstation. You can store them maybe in a separate storage area so that maybe there's appropriate, there's a way you guys are able to discard this particular reagent. So you store them away from the working reagents. An expiration date must be signed, the expiration date must be assigned to a QC material that do not have the manufacturer provided expiry date. So, for example, if a manufacturer did not issue with you, did not issue an expiry date, there's some facilities that say once the reagent has been constituted, must be used within 1 month. So that is where now you record the expiry date of that particular QC material. You say do not use after 1 month. Okay, and then you must date and date that particular reagent. Then there's another term here they're saying an expiration date that changes upon reconstitution. That's what you just explained there. Because there are some reagents that say this reagent will be expiring in the next 2 years. So they're talking about 2020, maybe 2027 or 2028. But once you have reconstituted it, this particular date is no longer valid. So you must maybe determine the appropriate expiry date on those particular reagent. Preferably, they say within a month. Within a month, you must have used that particular reagent for stability. Then labeling of reagent must be recorded on a log, that is both either paper or electronic, rather than on the container themselves, provided that all the containers are identified so that they are traceable, the appropriate data in the log. This mostly happens when you're using reagents that maybe you need to keep on touching, restoring them. So at times that particular information is not legible. So it's important that you do, we have also a paper backup or electronic backup to show that this particular reagent, this is the date that you have prepared them. And if there are multiple components, reagent kits, the laboratory should use components or reagent kit only within the kit lot, unless otherwise specified by the manufacturer. Okay. This happens with maybe, for example, you have your calcium, and then you realize that the standard that you're using, or the control, let me say the calibrator that you're using, or the standard that you're using in this particular kit, you have already exhausted the standard and the reagent is still there and has not expired. So please do not get the standard from another kit. Maybe you have a new lot that has, or there is a new batch that has arrived. You go pick the standard form, that new batch. That is highly discouraged. Okay. Storage requirements. All QC material, reagent, and media currently in use must be paired and stored as required by the manufacturer. This one is mostly about how do you store them, and this is actually given by the manufacturer. If ambient storage temperature is indicated, there must be documentation that the defined temperature is maintained. Okay, everything. If they say you are supposed to store it maybe in a fridge, in an ambient area, in an incubator, it must be documented so that somebody can be able to say that we received this particular reagent on this particular date. What was the temperature of the room? What was the temperature of the freezer? What was the temperature of the incubator? So that we have documentation of, somebody can be able to go back and walk through and see how we have been storing this particular reagent. A corrective action is taken when tolerance limits are exceeded. This one is mostly, the information is mostly obtained from the temperature logs. And the temperature logs must be utilized to document the acceptable ambient temperature ranges and record daily actual temperatures. The easiest way for you to be able to do this and to see that you do not have reagents that have exceeded the limit, the tolerance limits, is you take from the top. Maybe you have a reagent that you need to store between that, maybe between 25 and 30, and you have another one that you need to store between 24 and maybe 28. You take you take the high on the lower end and take the low on the upper end. So for example, in this scenario, you can take 25 all the way to 28. So that now you, even if the reagent was saying you store it between 24 and 28, and now you have another reagent that you need to store between maybe 25 and 30, now you have to take at least a minimum of that 24 and 28, because this reagent, the second reagent, will be falling within acceptable limits. But if you put between 25 and 30, once you document a 30, and this reagent is supposed to be stored not more than 28, you must generate a CEA. That's an easy way for you to be able to make sure that you're able to track all your reagents that you are storing, and they fall within the acceptable limits. Let be as narrow as possible so that you do not have so many CAs generated because of the exceeding the tolerance limit. Then acceptable ambient temperature range, record daily actual temperatures and allow the documentation of corrective action taken if acceptable temperature ranges are exceeded. The temperature tolerance limit must reflect the most stringent, we have said, most stringent of all reagent supplies. And they have given an example, maybe a reagent A that has a range between 20 and 28, and another reagent B that has a range of between 23 and 30. The tolerance limit must now, for the most narrow path they have there, is between 23 and 28, because both reagents, if they're between that particular temperature range, you're safe. So the laboratory must have established documented inventory control system. This one is another standard about the inventory control. That is the J, the inventory control. The inventory control standard says that there must be evidence of systems that highlight the need to place supply orders, receive, and track orders, and define the alternative plans for delayed deliveries of supply and recovery procedures for out-of-stock conditions. Okay, so for example, most of the time, you must have at least a minimum of 2 suppliers, so that in case supplier A either run out of business or they have run out of kits, at least you can go to supplier B. And the other way you can be able to do is maybe as a facility, have a way of having a minimum reorder levels. And the minimum reorder level, most of the facility, they work with a 2-month supply. The minimum reorder level must be around 2 months, so that in case month 1 you don't receive, you don't shut down. You still have another extra 1 month to operate. Okay, so the laboratory storage area must be sufficient to maintain an appropriate amount. That is the working supplies and reagent, appropriate levels for working. So the idea is do not overstock, and also you must have a minimum reorder level. So avoid overstocking and you define the amount of working supplies that you need to work with, so that you are able to handle the current workloads and demand of your facility. Then all storage areas must be temperature controlled. So you must have these temperature devices, monitoring devices that they also must be well maintained, so that you're able to know that the temperature that you're getting is within the range. And then must be strata-free and allow ease to determine the supply levels. Just by looking, you can see that maybe our diluent, we are remaining with the minimum reorder levels, or maybe our calcium reagent, we are remaining with 1 pack. Maybe that is our reorder level. It must be easy for you to be able to determine. There you have structured your storage, but it must be easy for you to determine whether are you working with working supplies, or are you running out of this particular supply. All storage area must be temperature controlled already determined. If reagent and supplies are stored in a centralized area, maybe for major big research facilities, they have a store. Like that is a centralized area for you to store your areas. Outside the laboratory, they must be stored and handled in accordance with the manufacturer's instructions. So if something is supposed to be stored in a freezer, and you maybe have a freezer farm down there, you can be able to maybe monitor your reagent in the freezer and have those temperature logs. So it doesn't matter whether it's in the lab or it's in a centralized storage area. All the manufacturer's recommendation or instructions must be followed, even if you have the bulk orders there, and must be checked and recorded on daily basis. And also make sure that your thermometer is well calibrated and well maintained. So the case standard, the standard case, we're talking about the parallel testing, lot-to-lot testing, and reagent equivalency, or what we refer here as lot release. So the goal of parallel testing or lot-to-lot testing and reagent equivalency is to, one, provide an appropriate, or to provide an approach for lot verification, and two, it is for use. The processes are used to demonstrate equivalency of testing material with prior or in use lot to ensure quality is maintained throughout the distribution process. Just to make sure that the reagent that you are now onboarding is of similar quality, not of inferior quality, so that you have a smooth transition between one reagent to another. Then for each new lot or reagent, the laboratory must document that samples are tested in parallel for each current lot, and that applicable and comparable results are obtained before all or currently the use of with their use as applicable. This is just for you to be able to maybe say, we've changed this lot, we use around 5 samples as our lot testing, so that now you have documentation to show that you have onboarded a new lot. And as we already said, when you're onboarding a new lot, you must also include a QC run, this particular. So a QC sample will also be able to help you to determine whether you have maintained the quality that the previous reagent was was on board has a comparable results. Then the qualitative and wave test, a minimum was checking include the testing at least one positive and one negative sample. Okay, so as I already said, a weak positive sample is recommended in this system, where participant test results are reported in that fashion. Okay, so we have for samples examples of suitable reference materials for qualitative tests include for you to do your parallel testing, lot testing, and reagent equivalency. You must have a positive and a negative sample tested in the previous lot. This applies for a qualitative test. Okay, previously tested proficiency testing material, especially if you had an EQA run recently, can also incorporate in that particular, can be tested in the parallel testing or lot testing. Then we have control stains of organisms in the previously identified organisms, mostly for microbiology department, microbiology reagent used to detect or evaluate culture microorganisms, mostly for gram stain. We need to have the two organisms, that's a gram positive and a gram negative. For also EQA materials, as we already said, that you have tested using the previous lot. So either proficiency testing material or the EQA material can be used. And then finally, if none of the above options is available, control materials must be provided by the assay manufacturer of the new kit that you are using. Okay. Mostly, there are some kits that come with a QC material. There are some kits that have an inbuilt QC material, and there are some kits that do not have either. So you must also evaluate because maybe, for example, for your sugars, you do maybe capillary blood. So in that particular scenario, you do not have the QC material, and maybe you have not enrolled in an EQA program. So you see now you do not have a material. So the kit itself must be accompanied with a QC quality control material in there. So control material so that you're able to determine whether the previous lot and the current lot are able to give you the comparable results. And it's also important that you do not run out of reagent so that you have at least comparable test between the previous lot and the current lot. Can continue for quantitative non-wave test. While participant specimen should be used to compare the new lot against the previous lots when possible. Okay, this is there's a caveat there when possible because there are some scenarios where it's not possible. The manufacturer material such as EQ and QC material may be affected by the matrix interference between the different reagent lots. So that's why you're using at least a QC material so that you see whether, and then to see whether they're comparable between the old lot and the new lot. Even if the results show no change following reagent lot change, use a participant sample, confirm the absence of the matrix interference. Okay, so as much as we may want to use our QC materials, both EQ and IQA, it's also important to have a participant sample in the mix down there when you're doing the runs. So the QC materials must also be run when comparing old and the new lots. The following materials may be used. Participant samples, as we had already said, are tested on the previous lot. Reference material or QC product provided by the manufacturer with the method specific and reagent lot specific reagent values. EQA materials with the peer groups established mean, with the established mean, because there are some labs that they work together so that we have this EQA material between interlab comparison or interlab testing. So that one, you can have a peer group where now you share materials. And even some of these EQA platforms, they can give you, this is your peer group, determined by maybe your area location, the equipment that you're using, and so forth and so forth. And also the reagent that you're using. So they can be able to pair you with your peer groups. Then the QC materials with the peer group established mean based on the inter-laboratory comparison that is method specific and includes data from at least 10 laboratories. This mostly is done by the EQA providers. Then the third party, which I know at some point, this has been hammered to the labs. At least we have third party QA materials, third party generated purpose reference materials. If the material is affirmed in the package insert or by the method manufacturer to be interchangeable with participant specimen of the method. So this one is mostly done where maybe we have procured this equipment with this particular manufacturer. It's recommended that you do not buy the EQA material from that manufacturer. Get at least a third party reference materials so that now there's a way you can be able to see how the equipment is performing out there. Then the QC materials for the current lot. The QC material for the current lot may be used to check a new shipment with the same reagent lot. And there should be no change in potential matrix interaction between the QC material and the different shipment, the same lot number reagent. I think that point we have already hammered very well. Second last, we are talking about the water quality testing. So about the water quality testing, there are some tests that require specific water qualities. And this one is mostly determined by the manufacturer. They may say that we need a particular water with specific conductivity, resistivity, pH, temperature. So depending on the manufacturer, the way they have recommended, then you need to have specific water documentation and how you are going to be able to document this particular water requirements. So there are specific water types required. This one is mostly determined by the manufacturer because there are some media that maybe require water to be of a certain pH. They're doing your microbiology. There's some tests that require that the microbiology analysis may be of this particular quality. So it's important that you have a documented policy that defines the standard and the frequency of water testing. Each water type has different specification for minimum microbial content, electric sensitivity, and total organic carbon levels. So it's important that you have at least a monthly check of these particular parameters. We have said the conductivity or the resistivity, pH, temperature, and also for microbiological analysis. Uh, Most facilities, they do it on monthly basis. There are some that say we are going to do a quarterly basis. There are some that say we're going to do it on monthly or maybe semi-annually. So depending on the requirement of the protocol and also the requirement of the reagent that you're using, and also according to the manufacturers, mostly go with the manufacturer's recommendation so that you're able to have this particular thing documented. The laboratory must ensure the records of the water testing are complete so that you don't have gaps in your documentation. And the laboratory must document evidence of corrective action taken when the water testing does not meet the defined tolerance limit. So this is part of the documentation. And then when decontaminating the clinical analyzer, water reservoir, this one is mostly done on a monthly basis. And the water storage containers, manufacturer recommendations should be followed to avoid problems linked to the poor water quality and due to the contaminants. Mostly it is the algae and microbiome that are able to contaminate your reservoir, water reservoir. Also, when you're receiving this water, you must insist that the supplier provides you with a certificate of analysis, and this must be maintained. At least when you're buying the commercially available waters, you must have this certificate of analysis. Because doing this particular test, electric conductivity, pH, and temperature, at times it may be a bit expensive for the organization. And then finally, let's talk about this one is mostly on the microbiology department, that's the QC of the media. So depending on the media that you're using, selective media, enriched media, whichever media you're using in your facility, performance of complete quality control by the user should include a visual and contamination check of your media to verify acceptable growth and inhibitory properties with appropriate bacterial and fungal control organisms. So you might inoculate, maybe you're using a selective media and you know they're supposed to inhibit the growth of particular organism. You can take that particular organism, inoculate it on your plate, then incubate it for at least 48 hours to see whether there will be any growth obtained. The laboratory are strongly encouraged, regardless of the media exempt status, to confirm the ability to support growth for all media use for the recovery of microbiological organisms. To monitor the performance of the in vitro susceptibility test is for the sensitivity testing. It is necessary to know the acceptable viability is expected in expected results using appropriate QC strains. These are mostly commercially available. The QC strains are mostly commercially available. Then document all the media QC activities and corrective action. Identify or correct the cause of any media failure. In case you have a failed media, you discard all the plates, then you do a new batch. Okay. And if the QC strains are not, you cannot be able to access them, you can still contact your peer pool or peer group to be able to get for you some of these particular organisms. And you can also contact maybe your fellow colleagues there who can be able to, once they have isolated a particular organism, you can store that particular batch so that you know that this is your in-house QC material that you've generated in the laboratory. Because some of these QC strains are a bit expensive when you obtain them commercially. So I want to end the presentation there, and I want to take this particular session back to our moderator, George Osimbo. Thank you. So back to the moderator. Okay, so from my end, I don't know whether you guys can hear. Uh, from my end, I can't hear anybody speaking. Okay, so I have seen some few questions here. I'll start with uh, the first question is, in case of malaria QC, what's the approach? For example, of positive control slides are out of stock, but there are negative control slides available since the malaria QC is supposed to be done daily. Can you run only positive or negative controls? The best thing about the malaria slide is that the storage duration for the malaria slide is quite substantially long. Because once you have, especially when you have a positive, if you have a positive malaria slide, it's recommended that you use that particular sample that you had already tested and it was positive. You do multiple slides so that those particular slides act as your positive control. And then you can have some stained and some not stained, so that when you are changing the your genes are stained. Now you can use those particular previously stored slides to act as your QC material. I hope I've answered that particular. But it's not recommended that you do a negative run all the time. At least have a positive and a negative so that you're able to see whether this particular stain that you have or this new batch you have is able to stain your organisms. Then the other question is, why do you insist on weak positive during a QC run? It's important that there are some kits that have very low sensitivity. Okay, since you want to establish that this particular kit will always give you a positive, will give you it's a positive, it will give you a positive, and if it's a negative, it's able to give you a negative. It's important that you are able to have a weak negative. It's important, even if you don't have a weak negative, you can dilute that particular reagent or that particular sample so that it becomes a weak negative. This one is able to give you an insight of whether your reagent have your kit is able to pick on this particular organism or not. That's why we are actually very keen on having a weak QC run a very weak positive when you're doing your QC. Then the other question is, EQA may not be run for every lot since the scheduled distribution of SAM is biannual or annual. Comment on that issue. Okay, so Stanley, yeah, it's not possible to have EQA sample every time, but it's recommended that you have it. And then, as we already said, when appropriate. When appropriate means because there are some EQA samples, once you have done like 1 or 2 runs, that particular reagent or that particular QC material runs out, or depending on once you have reconstituted it, there are some QC material that I have instruction that you cannot use it after maybe 2 weeks or after a month. So depending on the stability and the matrix of this EQA sample, that's why we are saying it's recommended that you have maybe an IQC, that internal quality control material, or participant sample included in the run, because we know that it's not possible all the time to have your EQA material available in your facility. Then should consent be sought from clients if their samples are to be used for validation, especially in HIV testing. So what most of the studies do, most of the PIs do, they have a caveat there. They say this is the reason you are going to do it, or any other, so that now the participant may ask which other test can be performed on this particular sample, the sample that I have provided. And this one is mostly asked also by the sponsor. How are you going to handle this particular clause? So that's why there's a way that when the PI is developing this particular study, they have a line there where they include that the samples be used for this particular session or any other session. But the participant also knows that this sample can be used for QC, can be used as a reference material, can be used for lot-to-lot validation in that particular session. But that's a very
good Mr. Chege, there another question here from Mr. Paul Kahara. Yes, thank you very much, Mr. Paul Kahara, for appreciating the presentation. I hope, Chege, you can hear me. Mr. Chege, I don't know if you can hear me.
Yes, I can hear you.
Great.
You see, what's the approach? For example, of positive control slides are out of stock, but there are negative control slides available since the major procedure is supposed to be done daily. Can you run a negative control? The best thing about the negative slide, the stage relation for all of substantially strong, because once you have, especially when you have a positive, if you have a positive malaria slide, it's recommended that you use that particular sample that you had already tested. You can put it here. You do multiple slides so that those particular slides act as a visual control. And then you can have some stain and stain. So that when you're changing the your beams aspect, now you can use those particular previously stored slides after, yeah. See, hope I've answered that. But it's not recommended that you use negative and at least have a positive and negative, so that you're able to see whether this particular stain that you have, this new part you have, is able to stain your organism. Then the other question is, why do you receive from this positive thing? It's important that there are some kids that have very low. George, I don't know whether it's on my end or it's in your end, but I can't hear you. Yes, hello?
I think we've lost a presenter.
Hello, I'm here.
Mr. Chege, I don't know if you can hear me.
Yes, I can hear you. It's on my end. I can't hear you guys. I don't know if you can hear me.
Okay, no problem. We just lost you briefly, but we are proceeding on well. I think you can proceed with answering the question that you are handling. And if not, and it is that you had answered it fully, we can proceed. Time is moving very fast, and also there are a lot of questions here. And I think we can resume from this point. Yes, there is Paul Kahara, who has appreciated the presentation and actually saying, well done, David. That was insightful. Alongside that, Paul Kahara has 3 questions. One is seeking for your highlight on how to calculate QC limits using the 20 replicate. And 2, how do you overcome biasness of your test method when deciding to use lab calculated values instead of manufacturers provided values? And number 3, how can a laboratory intermarry ISO 15189, 2022, and GCLP guidelines? Yeah, so you can just start with the first one, highlight on how to calculate QC limits. Just some brief highlights using the 20 replicate. Over to you, Mr. Chege.
Okay. So for you to generate the CV, you need a minimum of around 20 replicates, which can be generated from the samples that you do have. This one is mostly for you to generate your own mean and the standard deviation. So especially for quantitative tests is very easy because you can just use your Excel sheet, put the 20, just put 20 results for participant 1 or the to participant 20. Then from the Excel sheet, you using the formulas, you generate the mean, then generate the standard deviation. Then from there, you can be able to calculate the CV because they say CV is standard deviation divided by the mean. That way, you'll be able to have at least a locally generated mean and your standard deviation from the local samples or the local participants that you do have there.
Okay, the second one, how do you overcome biasness of your test method when deciding to use laboratory calculated values instead of manufacturers provided values?
So for that one, I do not have a concrete answer. Maybe I can get back to Paul later on.
Okay, that's well noted.
Yes.
I think more information can be sorted for that. And now we have ISO 15189-2022 and GCLP guidelines. How can a laboratory intermarry the two?
That is very good. So for ISO 15189, is mostly when you want your lab to be accredited, and you have that particular guideline to be used. But if you want to use this particular GCLP, dates GCLP, there's an accreditation process that is done for the dates team. And then this one mostly works with CAP. CAP accreditation mostly uses this particular setup of the GCLP. But once you're able to meet all the ISO 15189 2022, you can see that they are like a mirror image of each other. All these GCLP, you'll have met at least 90%, because the only thing that now comes here is the participant safety, and the other one is talking about the patient safety. So it's always just some few recommendations by the donor or maybe the sponsor of this study, but now you have to marry with the GCLP. But for the ISO 15189, is mostly for institutions that they really want to be accredited or follow the ISO standard. But the two of them, if you look at them very keenly, they look the same. They're almost the same.
Great, that's wonderful. I hope that Mr. Paul Kahara has got adequate answers on that. And if maybe there may be some input that Mr. Paul you'd like to add, yeah, you're free to just clap your hand and then I'll give you the airtime for you to speak. We can move to the next question. Now, this is about the media QC. You're doing quality control for culture media. Now, can you incubate the media without any organisms to check on the quality of the media? That's Mark Quoba.
Yes. Especially for the enrichment media, it's recommended that you incubate that particular plate for at least a minimum of 48 hours to see whether there was any contamination.
That's great, straightforward. Thank you very much for that. Crispin Athowe. Now, Crispin Athowe is writing, you talked of setting lab linearity values for reagents and equipment. How is this possible? How is it possible to set lab linearity values for reagents and equipment? Yeah, that's Crispin's concern. So maybe you can give some brief highlight on setting lab linearity values for reagents and equipment.
Okay, so when you're setting linearity, you need at least a minimum of 3 data points. So what most people do, because already you do have the lower limit and the upper limit from your QC material. So those are 2 data points. Those are 2 data points. So for the third data point, or the fourth data point, what you do, you just take the high, that is your pathological sample for the high value. Then you do some serial dilution, like 1 in 1, 1 in 2. Then you have an extra data points. Then using those data points, you can generate a the linear curve for this particular reagent, for this particular test. That's how most of the labs do it.
Great, that's wonderful. Thank you very much for that. Well, thank you very much also, Paul Kahara. I acknowledge your reply. You're saying, thank you, David. That was well answered. So we appreciate you for that. I think Chris Fin's Athoe's question brings us to the last question to be tackled in our Q&A section. Other than that, there are some questions that I've streamed here in the chat area. Okay, I can see that it's the same that we've handled. Thank you very much, everyone. We've got very many participants here appreciating your presentation, Mr. David. And actually, Mark Koba, who is one of the participants who asked you one of the questions, is actually appreciating and is saying, thank you, Mr. Chege, for the elaboration. Maluma Makulomba is saying, nice presentation. Thank you very much, Maluma. I acknowledge your presence. That's great, quite encouraging. Zipporah is also appreciating your presentation. Eric Getish saying, nice presentation. Quite a number. Thank you very much, everyone, even for your presence and also for supporting Lab Medicine Society of Kenya and also entrusting us for this service. So without much ado, I'd like to bring on board once again our presenter, just to give us a parting shot concerning this session, any observation or any maybe a nugget that maybe you can share with us. Just a 1 minute statement, Mr. David, that you can share with us as we part. So over to you, Mr. David. You can take some few seconds to 1 minute just to give us a parting shot as we come to a conclusion. Over to you, Mr. David.
So thank you so much, Tim, and my colleagues who are out there for the support. And it's a learning process, what I can say, because there are so many things that you can be able to get out there. Like I had said earlier, you have the Lab Quality Management System Handbook for the WHO. You can use the dates, you can use RCA, you can use the ISO 15189, and so many other materials which are out there to be able to guide you in terms of quality improvement of your facility and in your organization, and also build on whatever you're currently doing. So as I leave, I also want to encourage the team members to also be able to facilitate such particular or these particular sessions, so that you can also have an insight of how these things are done. And I also want to encourage to thank the management of LMSK for the opportunity they have given me to be able to present this particular session to the team members. And as I already said, we have 11 modules. We have already covered one module, that is module 4, the test and control. So you can go and check on the others, all the way up to the last session. They say it's just a second. So the final one is quality management module for this particular GCLP. And it's a very neat and small document, around 66 pages. I can have a look at it, get more insight. And in case you have any queries, you can always reach out to me. I know there is quite a number out there who have my number. And feel free to call me, and we can be able to have a deliberation and see how we can be able to improve the laboratory.
Great. That's
Quality.
wonderful. Mr. Cheke, we really appreciate your presence and also your time. On behalf of LMSK, we say thank you to our members, the participants, medical laboratory practitioners who've found time to participate in this webinar. We say thank you very much. We are open also for more webinars. We conduct our webinars on Mondays, Wednesdays, and Fridays. And so feel free to join and gather knowledge as we grow in this profession. At this time, the time has cut as short. And so on behalf of LMSK, allow me to bring this webinar to an end at this time. So to everyone, we wish you a blessed evening, and let's meet the next day that we'll have our webinar, which is on Wednesday. Thank you very much. Thank you, and may God bless you.